This video will demonstrate how to use Excel to calculate the Shannon index of diversity. These data that are shown in this spreadsheet are data of the number of individuals of each of these species that were found in a forest plot. And so I want to use these abundance numbers to calculate the diversity index of the entire woods based on these data. So the first thing to do in order to make this calculation is you need, so let me back up. So the diversity index is calculated as the sum of the proportion times the natural log of the proportion, where the proportion, the p sub I in this formula, is the proportion of alternate leaf dogwoods for this first species, if I is alternate leaf dogwood. The proportion would be the proportion of the total number of trees that were the alternate leaf dogwood. So the way you calculate that p sub I is you take 5 and divide it by the sum of all of these numbers. So the simplest thing to do is to calculate the sum. And so I'll just write in sum, and we'll use the formula in Excel. Excel formulas always start with an equals. So equals sum. You can double click on that, and then it automatically puts in a parentheses. And I want to have Excel calculate the sum of this array of numbers. So I close my parentheses and hit enter. So the total number of trees counted were 30. 5 of them were alternate leaf dogwood. So to calculate the proportion, I again use an Excel formula, which is equals, and then I click on this cell that contains the number, the count. Turns out it's B2. Then divide that by the sum that I calculated, and then I hit enter. So the proportion of alternate leaf dogwoods in the entire amount was 0.16, about 17%. 17% of the trees were these alternate leaf dogwoods. Now I can copy that down, but I want the B11 to stay in the same place. So I want all of my formulas to have B11 as the denominator. So to tell Excel to keep this formula stable, I'm going to put a $sign in front of the B and a $sign in front of the 11. Then when I copy this down, each index is still going to have B11. So for the bur oak, it's going to be 1 bur oak tree divided by the total of 30, which gives me about 3%, 0.03. Now, just to make sure that we've done our calculation correctly, we can find the sum of the proportions, and they should add up to 1. So I can just drag my sum across, and that should add up to 1. So that makes me feel a little bit better if all my proportions add up to 1. Now we can take the natural log of each of these numbers. Again, you can use a formula. And if we type in ln, we can see ln returns the natural logarithm of a number. So that's what we want. It automatically puts in parentheses, and we want it to calculate the natural log of that proportion. So close parentheses and enter. Notice that we get a negative number, and all of these are going to be negative as we calculate that. And so that's why when we get to the end, we're going to take the negative of this number because we don't want our index to be negative. Third step is to multiply the proportion by the natural log of that proportion. So we simply multiply the numbers in each of these two columns. So again, we start with equals, click on the C2, which is the proportion, enter the asterisk, which is the sign for multiplication, and then click on D2, which is the natural log of that proportion, and then enter. And again, we can copy those numbers down. And now we have p sub I times the natural log of p sub I. To calculate the index, we want to find the sum of all of these numbers. For each I, we want the proportion of I times the natural log of pi. So we've done that for each of the i's. Now we just need to sum. And so equals sum of all of these. Close the parentheses and we get negative 1.9. So H is going to be equal to negative, and I'll just put a parentheses. And so I've just calculated the negative of the sum of the p sub I times ln p sub I. So this number is not super high. If we had a number close to 5, that would indicate high diversity. If we had a number close to 0, that would indicate very low diversity. We have kind of an intermediate number, 1.9, almost 2.0. And that's how you use Excel to calculate the Shannon index.